Okay, so this time we'll take a look at detection of faults using the path sensitization method. Now, here you will probably be asked to find the text vector, right, which will detect that B is stuck at 0. Okay, so when you take a look at the diagram, you realize that it's clearly indicated that B is stuck at 0. Okay, now the assumption you make here is that fine, there are several ways you can go about this one. Okay, but the best one is, first, assume that if B is stuck, then we will wish to propagate its fault way to the end. Okay, so now let's try to take the upward path. That is, I'm talking about the path from B through F, through H, through K, then through L. Okay, now in that regard, then let's assume that B has a Boolean value, right? Although we know it is stuck at 0, let's assume it has a Boolean value D. Okay, we are doing this so that we can see the error, because you can't differentiate 1 1 from another 1 or 1 0 from another 0. That's why we are using D. Okay, now if that's the case, then it means that at this point it is D that will appear here. Okay, now if you want to propagate this error forward, right, it means that we have to let A to be equal to what? 1. Okay, then I mean, when you do Boolean logic, 1 and D will give you D, right? Now you see the advantage of using D. If I had chosen 1 for here, then I'll get one other output and I wouldn't know whether how it was coming about, but at least I know that it is because of the error that D has propagated forward. Now you have D and J, right? But the only way we can propagate this error forward is to make sure that here is 0, because this is an OR gate, right? So that when this input is 0, then the other input will go for it, because you realize that we have A or 0, it is equal to A, right? That is all logic. Okay, so that's what we are going to do. So we are going to put 0 here as the assumption, and we'll propagate that one forward. Okay, so it means that at the end of it, they'll have D or 0, which is D. Then we come to another AND gate, and in the other AND gates, because we have D into an AND gate with E, we have to make here 1, so that was the error D will propagate for it, right? But before you come all the way, right, anytime you assume a logic value for another output gate, right, try to go back and see if it's reasonable. So remember, at this point we put 0 here, right? Now the only way this one can be 0, assuming there is no fault in this device, is that here is what? 1. Okay, and the assumption that here is 1 cannot be satisfied, like really justified, right? We can't justify that assumption, right? What it means is that then we cannot take this upper part, right, going through this, because we can't really justify that assumption that here is 0 and here will be 1, assuming that the error coming from here will produce a 1 here. Okay, so we can't justify that assumption, so we go back and let's start the whole procedure again. Okay, this time let me use a red marker. So starting the whole procedure again, I'll still assume here to be D, but this time I'll take the lower part. Okay, so taking the lower part, it means that D will come here, right, and here has to be 1, so that we can propagate the error forward. Now when here is 1, the error that will be propagated will be what? D, right, because 1 and D is D, right? And assuming this gate is working, then we'll have what? D bar here. Okay, now since we have D bar here, we are entering an OR gate, right? And an OR gate, because you're entering an OR gate, the lower one is D bar, so the upper one has to be 0, right? Again, we have assumed another logic for a different input, so we have to propagate it backwards. So when we come backwards, When we try tracing backwards, we are saying that the output of this has to be 0, right? And that is possible if A is for 0. Remember, A is not coming from a faulty test. You see, B was coming from a faulty test. That's why we couldn't work with it here, right? But A is not coming from a faulty region, so we can immediately say A is 0, and that's right. Okay. Then it means that our backwards part works, right? So we'll propagate it for it. D and 0 will give us D bar here. Okay. Then in that case, if we have an AND gate between D bar, then we have to put 1 here. Okay. So that the error propagate first. So the final output should be what? D bar. Okay. Now the whole point is that we have propagated the error for it. We have been able to propagate the error for it so that we can generate our test vector, right? So our test vector should be such that E is 1, right? C is also 1, right? Then for path sensitization, if B is stuck at 0, then B should be put to 1. Okay. Then A should be put to 0. So our test vector will end up being 0, 1, 1, 1. That is A, B, C, D, and A, B, C, sorry, because those are the inputs. All right, yeah, so I think that simplifies it. Thank you.